So welcome to this. This is the Further Math Support Program online revision session for Specification Edexcel Statistics 1. And in this session we're going to be looking at probability, Venn diagrams and tree diagrams. For Edexcel we need to be able to use effectively the sum and product laws, so they link to dealing with mutually exclusive events and aspects of conditional probability. We need to understand and be able to use how independence of two events work. We need to be able to draw sample spaces, tree diagrams and use them, Venn diagrams and use them, and of course the feature that makes this a lot more difficult than GCSE is the aspects of conditional probability. So the first question I'd like to look at is one that is quite familiar to many students who have studied GCSE higher tier in particular, and it's asking you to draw a tree diagram to illustrate possible outcomes and their associated probabilities. Okay, and you're given 3 marks for this. Fundamentally you get 1 mark for getting the correct structure to the tree, and there's something I need to say about this as well, and then 2 marks for getting the correct probabilities associated with them. So we can either, on picking the first bead, have a red, a blue or a green. So we're quite happy to use R, B and G. And the probabilities are as follows. We have 2 out of 4 which are red, 1 out of 4 which is blue, and 1 out of 4 which is green. Now you're under no obligation to simplify these fractions, and in fact if you do it can cause problems, certainly if you are not replacing like it is here. So once we've chosen a red one, we can then choose a red one, a blue one or a green one. But now we have to realize that there are 3 in the bag, which is why all of my probabilities are now out of 3. There is 1 red, 1 blue and 1 green. So that's fine. If I've taken a blue out of the bag, what we need to realize is there are no more blues, sorry, in the jar, not a bag. But blue can't happen because I've taken them all away. So that's red, which is 2/3, and green, which again would be 1/3, sorry. Now you could put an additional branch on that says 0 for blue. Okay, if you put a branch on for blue, you must make sure it's got 0 on it. That is permissible, although we don't like it. Same with green. If you've taken a green out, you have no more greens left, so we can only choose a red or a blue. So there are 2 reds in the jar and there is 1 blue in the jar. So just to reiterate, there are 3 marks available for this. The method mark is for effectively getting the structure of the tree diagram correct, and the accuracy marks in both cases are assigned to getting the probabilities correct on the branches. Okay, so here is the tidied up one, and you can see on the mark scheme they have simplified a half. I personally prefer to keep it as 2/4. It just keeps all your fractions nice, it keeps all your denominators the same, and potentially can just make the maths a little bit easier to do. So it says, find the probability that a blue bead and a green bead are drawn. Now it doesn't say that the order is important, so either way is fine. So blue and a green is that outcome, or I could equally get a green and a blue, which is this outcome. So this is worth 2 marks, as we can see, 1 for demonstrating both of those probabilities and adding them together, and then your accuracy mark is for actually getting the correct answer. So we've got 1/4 times 1/3, that's the first root, that's this one, or we've got 1/4 times 1/3, and if we work both of those out you get a value of 1/6. Okay, so we're now moving on to some of the more difficult questions. Here we have a Venn diagram question. We're asked to draw a Venn diagram, and they're worth quite a lot of marks. And there's lots of things you need to remember to do. If you don't do them, each time you don't do it, you lose a mark. So fundamentally with this, we've got 2 method marks, 2 accuracy marks, and an independent mark. So the independent mark is given if you have 3 things: labels, you have the correct value outside of the circles, and you have a box. So drawing a box around your Venn diagram is absolutely critical. You then get method marks for two things. First of all, for making sure you've got the correct structure to your Venn diagram, and we'll look at that in a minute. You get another method mark for demonstrating that you're using the information correctly, and then it's making sure all the right numbers are in the right place to get the two remaining accuracy marks. So first of all, we've got three things. We've got developing software, networking, and systems support. So we need to label these things. So I'm going to call this one D, I'm going to call this one S, and I'm going to call this one N. So D for developing, S for systems, N for networks. Now when you start to fill in a Venn diagram, it's really important that you start from what I call the most constrained case, which is this one. So we need to make sure that all of them are taken into account. So we've got 4 in the middle. And then we start working backwards. So we're told that 40 takes systems support and networking. Now, having filled in the 4 in the middle, I've already taken into account 4 of those 40 people, so that means I only have 36 that I need to put in. So this is where your second method mark is coming from, demonstrating a subtraction so that the intersection between S and N still adds up to 40. So we take each one in turn. So networking and developing software is going to give me 28, so I need 24 in that region. 35 for developing software and system support, so I need 31 in this region. So that's that section sorted out. We've then got 81 taking networking. So at the moment, if you look at networking, I've got 36, I've got 4, and I've got 24 in networking. So 36, 24, and 4 in networking. Okay, which is going to give me 64. So the rest of them must be in networking, which is 17. We do the same for each of the others. So developing software means that I'm going to have 11 because there are 70 in total. 112 takes systems support, so that means I'm going to have 41 here. Now again, you've not finished. It doesn't say that you have to take any of these things. Okay, so as a consequence, you should always expect there to be a number on the outside of the circles. Okay, so if you add all of these values together, okay, and then you subtract them from 180, you're going to get 16. So that must live on the outside. Now, please be aware there are no follow-throughs on these types of questions generally. Okay, so it's absolutely important that you get the numbers right. 5 marks is quite a lot for a question like this, but please make sure that they are correct. So we're then asked to do a few probability questions. So find the probability, that's the key thing, find the probability that this student takes none of the extra options. So we need to realise that that is 16 out of the 180 students. Now these are follow through, you'll be pleased to know, these two questions. So that means if your Venn diagram is not correct, but your answers here are correct based on your Venn diagram, you will get the marks. Now that's a perfect answer, 16 over 180. As I've said on other of these videos, we're under no obligation to simplify, but it's good manners too, so if you get time to, please do. Probability of networking only. So you need to realise where networking only is, and networking only is this aspect of your Venn diagram here. Okay, so we have 17 out of those 180. So that's just checking, and again, they're independent marks for each one, but they're just checking that you can do a Venn diagram, basically. It then goes on and it says, students who want to become technicians take system support and networking. Given that, so this is implying some form of conditionality. So given that a randomly chosen person wants to become a technician. So if they want to become a technician, they have to be doing systems support and networking. So I have to be within this region here. I don't have any choice over that. So really, I'm only dealing with 40 people before I even start. So it says, find the probability that this student takes all 3 extra options. Well, it's the 4 here that is the all 3 extra options. Okay, so you've basically done a conditional probability question by doing what's called reducing your probability space. You're looking at a subset of the whole system because it's telling us to, and you want to know the condition that we're dealing with. So again, it's polite to simplify these, and that's what we've got. So you get 2 marks here. You get 1 mark, in this case, because it's a Venn diagram, you get 1 mark for getting a denominator of 40, and then you get the other mark for getting the correct value. Okay, other questions on conditional probability require a demonstration of using the formula correctly, and I'll show you that in a moment as well. So, moving on to a slightly different question about tree diagrams, and this one in particular is quite demanding, and it's going to highlight quite a lot of things. So we're asked to complete this tree diagram, so let's just check we've got the information and the situation, and you really have to, as is good practice, to read the questions very, very carefully before you start answering them. So we're told that B has got 6 balls, 3 are red and 3 are yellow. Bag Q contains 7 balls, 4 are red, 3 are yellow. You're going to take a ball out of P at random and put it into Q. You're then going to take a second ball out of P and put it into Q. So rather nicely, they've then told you that there are 9 balls in bag Q. We're then discussing 2 events, which we'll come to later, but it says event A is when 2 balls are the same colour from P. Event B is when the ball drawn is red from Q. So to complete the tree diagram, first thing I would notice is this is really 3/6 and this is really 3/6. Okay. Again, I don't like simplifying fractions. So I know it's 3/6 because I have 3 out of 6 reds and 3 out of 6 yellows. So if I select a red, that gives me 2/5. But now I have 2 extra red balls in bag Q. So that tells me instead of 4 red balls, I actually have 6. So that's 6/9 and 3/9. In fact, we know they're all out of 9, so might as well do that to start off with. Okay, if we just work our way around, this is 5/9, so this must be 4/9. Likewise, so we've now just got to work out the bottom pair, so it follows a very similar pattern. If you've taken out a red ball, you started with 3 out of 6 red balls, so now yellow balls, sorry. So now we're going to have 2 out of 5 yellow balls, which means we now have 3 out of 5 red balls. And again, if I've put 2 extra yellows into bag Q, I now have 5 yellow balls. Okay, which means that this one again is going to be 4/9. So this is quite tricky, just getting your head around what's going where. So again, make sure you're very, very aware of the questions. So this was worth 4 independent marks. Okay, and I'll show you where they come from. So you get 1 mark for getting both of these values correct up here. Okay, your next mark is for getting this value of 4/9 correct. Your next mark is for getting 3/5 and 2/5 correct. And your final mark is for getting the other 3 correct. Okay? So everything is attributed, and that's how the marks are triggered on that particular question. It then starts to get a bit interesting. So it says the event A occurs when 2 balls drawn from bag P are the same colour. So really what's sometimes useful is to realise that drawing from bag P sort of has a line down the middle. Okay, so if they're the same colour, we're dealing with getting a red and then a red, or getting a yellow and then a yellow. And because they're independent, we're just multiplying here. So this is going to be a half times by 2/5 plus a half times by 2/5. So we can see working that through will give me 2/5. Okay. Now, this question, you cannot assume anything. Okay, it's very tempting to realise that to find the probability of B, you might want to use the multiplication rule. Probability of A intersect B is the probability of A times B, because you can see it. 2/5 times 5/9 is equal to 2/9. Okay, so there's some sort of, your brain is telling you something which isn't true. So please try not to make any assumptions with this. So we're told to show that the probability of B, which is choosing a red from bag Q, is 5/9. So you need to recognize that getting a red in bag Q corresponds to this value, this value, this value, and this value. So to do that, we're going to have a half times 2/5 times 2/3, or we can have a half times by 3/5 times by 5/9, or looking at the bottom of the tree, we can have getting a yellow and then getting a red and then getting a red out of bag Q, or we can get a yellow, then a yellow, then a red. Okay, that is, sorry, 4/9. That is sufficient to trigger the marks that are required. It's a 3-mark question, and you get a mark for identifying at least one of these there are 4 multiplications, but if you get one of these correct, you're going to get your first method mark. Okay, your second method mark is for noticing that there are 4 of them and you need to add them together. Okay, and of course, assuming that they're all correct, you will then of course get your accuracy mark as well. You can still get your method mark if your probabilities are not quite right, but of course if they are not quite right, you're not going to get 5/9. Now for part D, as I say, it's very, very tempting to use the fact that the probability of A times the probability of B is the intersection, but at no point in this question are we told that they are independent, so we are not allowed to use that. Okay, so we have to just think about the situation. So the probability of A and B, well, what does that mean? Well, it means that the 2 balls from P are the same colour and Q is red. Okay, that comes from the question. So we're looking at P being the same colour and Q being red, which corresponds to red, 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 and of course it corresponds to yellow, yellow, red. So we can work those out. So it's the probability of getting a red out of P and a red out of P and then a red out of Q, or it's getting a yellow out of P, then another yellow out of P, and then a red out of Q. And if you work those out, you can then see that you get your 2/9. So you get a method mark for identifying both cases this time. So I need to know, so you can, if I'd seen you write RRR plus YYR, okay, you'd get a method mark because you've clearly identified that you're dealing with 2 cases here. Okay, and then of course by writing out the probabilities and calculating it, you're getting the correct answer. So don't assume independence unless you are told that they're independent. Don't assume. Okay, so for part E it says hence, so you must use what you've just done, the union of A and B. So we know, using the additive rule or the sum rule, A union B is equal to the probability of A plus the probability of B minus the probability of A and B. So in this particular case, we've worked out that the probability of A is 2/5. We've worked out that the probability of B is 5/9. And we've just been asked to demonstrate that A intersect B is equal to 2/9. So once we see that, everything's happy. We can then work this through. Okay, and we're going to get 11/15. Now of course, if you've got the probability of A incorrect earlier, we will still give you the method mark. Okay, because you've done the right method. So as long as you've used your value of the probability of A, that's fine. And of course 11 over 15 will be the answer that's required. It then says for part F, given that, so again we're dealing with some form of conditionality, given that all three balls drawn are the same colour, so that is what would live on the denominator of the fraction. So we're either dealing with yellow, 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 or we're dealing with red, red, red. Find the probability that they are all red. So it's the probability of red, red, red over the probability of yellow, yellow, yellow plus red, red, red. Okay, which if we work out, red, red, red is going to be a half. And again, you may have worked these out already just by doing the tree diagram, but a half times 2/5 times 2/3 divided by the same thing, probability of getting 3 reds, I'll just do them in a different order, plus the probability of getting yellow, 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 a half times 2/5 times 5/9. And again, if we see that, we're incredibly happy to give you method mark and an accuracy mark. And then, of course, calculating it through, this gives you 6/11. If you get the correct answer, you will obviously get all 3 marks. So just to remind you, you get a method mark for getting effectively the formula correct. Okay, trying to use the conditional formula for this is a nightmare. So thinking about it is, in my view, a little bit better. So you get a method mark for that. Now, of course, if you've got probabilities that are incorrect along the way, we don't want to penalise you twice for this, so you do get some follow through here, but you do have to get 6/11 to get the full answer. Of course, this could all be done in decimals, but fractions are considerably more useful in this case. Okay, so over to another question now about Jake and Camille, who are sometimes late for school. And we're told what J and K are. J is the event that Jake is late for school, K is the event that Camille is late for school, and we're told some information. It is incredibly tempting to now draw a Venn diagram, and that is perfectly fine. The question doesn't ask you ever to draw a Venn diagram, okay? But you can, if you wish, and we'll talk about that in a minute. So part A, at least one of Jake or Camille are late for school. So that means that either Jake is late for school or Camille is late for school. Now, you might not be aware that this is the same as 1 minus the probability of not Jake and not Camille being late for school. Okay, some of you may be, some of you may not be. So you end up with 1 minus 0.7 equals 0.3. That's where the thought of doing a Venn diagram might become really quite useful. So here we go. We can have Jake, and we can have Camille, and we can start filling things in. So if we call this J and K, this is going to be 0.15 in the intersection, because that's what we're told. It's 0.7 outside. Now you can see that this is true. Okay, so some of you might be more familiar using Venn diagrams to see what's going on. Jake is 0.25, but don't forget that involves the intersection, so that's going to be 0.1. And that therefore is going to be 0.05 because all of those probabilities do have to add up to 1. Which is nice because the Venn diagram now allows me to answer part B. Camille is late for school. Okay, so we can now see from the Venn diagram that for part B, Camille being late for school is going to be, so Camille is going to be 0.15 plus 0.05, which is 0.2. Okay, so we can see this on a Venn diagram, but your Venn diagram must be correct. Okay, that is absolutely critical to make sure that it's correct. If you're not using Venn diagrams, okay, what we're looking for is some sort of, well, in my view, it's easier to draw the Venn diagram, but we're looking for the similar calculations. Okay, some way of finding the probability of K. But as I say, Venn diagrams is probably the way that most people are going to do this. So, given that Jake is late for school, find the probability that Camille is late. So, this is a pretty standard question. I'm going to do it without a Venn diagram. So, we're looking for the probability that Camille is late given that Jake is late. So, please make sure that you're using the letters K and J and you're not using the letters A and B. If we just see the formula copied out, and I'll just write the way it's useful to learn, you don't get much credit for it. So this is the probability of Camille and Jake being late divided by the condition, and the condition is that Jake is late. A lot of candidates, a common error here is to get this the wrong way round and end up putting Camille at the bottom. So be very, very, very careful with that. So we've got all the information we need. Okay, the probability of Jake and Camille being late is 0.15, and the probability of Jake being late is 0.25. Now you cannot leave your answer like that because it's not a fraction, they are decimals. Okay, so you do need to make sure that you change it round. So you get 3 marks for this. You get 1 mark effectively for using the correct formula. If we don't see this formula or evidence that you've used it, or you haven't used the right letters, so you've just used A, B and B and then not continued it, you will not get that method mark. Okay, which is 3 marks thrown away because it's method 1, accuracy 1, accuracy 1. So be very, very aware of that. Part D, we're asked to determine independence. Now, the easiest way of determining independence is to realize that the intersection has to equal the product of each individual probability. Okay, so we'll look at that bit first. So we know that the probability of J is equal to 0.25. We know that the probability of K is equal to 0.2 because we had to work that out. So 0.2 times 0.25 is equal to excuse me, is equal to 0.05, and we can clearly see that that is not equal to the probability of J and K, because the probability of J intersect K, and again it's always good to use words here, since the probability of J intersect K is equal to 0.15, therefore not independent. There are other ways. As I say, that's the way that most people would do this type of question. So comment on the teacher's suspicion in light of your calculation. So the teacher suspects that Jake being late for school and Camille being late are linked. Okay? So because they're not independent, this does confirm the teacher's suspicion. Not independent does imply that there is a link. So this is worth 1 mark. Okay, so you can't just write yes or no. You do have to evidence it. So for part E, you would say something along the lines of yes, since they are not independent. And if you want to just clarify that, you could say therefore are linked. Okay, or you could be more English based and say the teacher's suspicion is correct since, but anything just saying that would be correct. Okay. So again, there are lots and lots of variants of the questions that they can ask you, and it's really important that you work through all of the past paper questions because, again, as you've seen, tree diagrams suddenly get quite interesting. So you do have to be very, very careful and aware and make sure you understand the principles rather than just churning a handle to tackle probability questions.